Okay, so you've made it through the first unit and you're getting ready to write your unit test, and I'm putting a little video together so that you can, I can help you focus on what you should know for the test and what you should do to prepare for the test. So I'm going to put a few things down here first, but then I'm also going to walk you through a few things and just remind you of some of the things that maybe some people made some mistakes along the way, so this will be beneficial for everybody. First thing I want you to do, I'm going to post a review and I'm going to post a formula sheet. So first two things I want you to do, print formula sheet, print review sheet. Third thing I want you to do, work through the review sheet. With only the review sheet, or with only the formula sheet. The reason I'm telling you to do this is it's just going to test your knowledge to start with how much you remember from the unit so far on your own with just using the formula sheet. Because come test time, you're going to have a test, it's going to be timed, and therefore you need to be prepared. So you need to know before going into it what you know and what you don't know. And during the test, all you should have in front of you is the formula sheet, so that when a formula comes that you need, you can go to it and look for the formula that you need. But that's going to take for you to sit down and prepare and get a little bit more familiar with some of the concepts, some of the terms and things that you learn throughout the unit. So first thing I want you to start with, work through a review sheet with only the formula sheet for problems. So the problem, like the mathematical type problems. Outside of the math type problems, there are going to be some terms and definitions. So using my notes or Google, define the terms that I've given you on the review. So you might be asking, well, where did I learn these terms? Do I have these terms? So these terms are nothing new. I've addressed every single one of these terms in all of my notes. So if you want to, you can just go back to the PDF copies of my notes. You can write down the terms for these because these are terms that you should know for your test as well. Now keep in mind, on this time test, you're not going to have time to flip through all of your notes to figure out the answer because it is a timed test. So that's why I'm putting this review sheet together for you. Have the terms that you need to know for this test on one sheet that you can go to. That's why I'm saying take the next 2 days, so Wednesday and Thursday, to prepare. And then you also have the weekend to prepare. I've extended it just to give you that extra bit of time to get ready for that first unit test. So define the terms, work through the problems, try to only use the formula sheet for the problems, but if you have to go back to the notes, that's okay. You can do that too. Next thing. Once you've attempted it, email me with any questions you couldn't figure out on your own. And what I'm going to recommend is not to email me after each question you get stuck on. Work through the entire sheet and then email me with your collections. But before you do that, actually, I'm going to post a review answer sheet. So you're going to have the answers to check with. If you still can't understand it, where you went wrong after you've checked the answers, then email me. So first thing I want you to do is check the answer sheet, answers to review that I will post. Here's the thing though, I'm not in a classroom to watch you do this, but I am going to tell you, if you just go straight to the answer sheet, you're not going to learn anything. So what I want you to do is try these on your own first. Once you've tried every single one, so skip the ones you're stuck on, that's fine, but continue working through the rest of the sheet. And then once you've attempted the entire sheet, then go to the answers and check your numerical answers. I'm not going to provide terms and definitions because that's all been in the notes that I've given you so far, and or you can consult the web for that. So check the answers to the review. After you've checked the answers to the review and you still can't figure out one of the questions, feel free to email me, okay? So this is what you guys need to do between now and next Tuesday, because that's when the test is going to be available to you guys. Now I just want to take a couple minutes and just review some of the major concepts that you should be familiar with. So these are kind of like the big ideas or the big sections of the unit. Here's what we've done in them. So first thing, scalar versus vector quantities. Okay, there's one thing we've covered. I'm just going to put a whole bunch of different ideas here. We covered displacement. You should know the difference between these. When I put verses between them, it means we should know the difference. Displacement versus distance. Velocity versus speed. So really the only difference between when we talk about these two things, just to help you out, remember a scalar is any number, a vector, let's use a different color here and make it thin. Okay, a vector has direction. So it just means that it has an east, west, up, down, north, south, left, right. Okay, direction. Vectors, in terms of these things mean the same thing in terms of vectors. So this is a vector quantity, has to have direction. These two are vectors. Okay, when we look at displacement and we look at distance, they're calculated the exact same way. So displacement, just because it's a vector, has a little vector arrow on top of it, and distance does not. Displacement is basically where you started to where you finished using a straight line. Distance is adding up all your individual movements. So the total length of the path traveled. Displacement from start to finish only, using a straight line. So there's sort of a summary of that. Now when we're talking about velocity and speed, we learned some formulas. It's the same formula for both, so I'm just going to put it once. Velocity or speed is equal to distance or displacement divided by time. It's the same calculation for each. The only difference is that if you're talking about velocity, your final answer should have direction. That's it. They're calculated both of the same way. Okay? And remember, for every formula that you have, I gave you a magic triangle to work with, and you will have that on your formula sheet that I gave you as well. So if you don't have to, if you're not familiar with rearranging mathematical equations, you're going to have this as well to work with. So let's just review how that works. Figure out the one that you're solving for. So if you're solving for displacement or distance, you want to cover this one up, and it'll tell you what to do with the remaining two variables. So if there's a horizontal line, it's division between them. If there's a vertical line, you're multiplying. So if I were to make a shape that we could use here, fill, to use as our cover upper, if we're solving for displacement, cover it up. It means we have to multiply velocity times time. If we're solving for time, let's say we want to know how long something took, cover it up means we're going to take displacement or distance divided by velocity or speed. So this whole thing works for both velocity and speed. The only difference is that velocity has to have a direction in your final answer. So don't forget to put units and don't forget to put directions if it's one of the vector quantities. If it's not, then you don't have to. Okay. So where do we move on from that? So from here, then we talked a little bit about acceleration. And this just means that we're either speeding up or slowing down. And we learned that acceleration is equal to our change in velocity, so v2 minus v1 over time. Another way of writing this is just change in velocity divided by change in time. And so that looks like this. And we had another magic triangle. So all of these are going to be on your formula sheet, don't worry. You just need to know how to use them. So acceleration equals velocity over time. Okay, now we looked at all of the math behind this and solving those problems, but at the same time, and I'm just going to scroll down here a little bit, we learned about interpreting graphs. So this was another thing we talked about, and I'm just going to recap. If we have a distance time graph and we were to plot it and it's a straight line, then we should be able to take the slope of this line by picking 2 points and figuring out the change in your rise divided by the change in your run. And this tells us the slope of that line, which equals rise divided by run. And that also tells us the velocity, or speed, average speed. So when we find the slope of a displacement time graph, we're actually finding velocity because we're taking the units of meters and dividing them by the units of seconds. So if you think of meters divided by seconds, we end up with the units that represent velocity. Okay, we did a similar thing with a velocity time graph. If we look at a velocity time graph, or speed, and we take the slope of that same line, so pick 2 points on your line, figure out what the horizontal change is and the vertical change, same way, same calculation, but we're dealing with different units here. So what happens when we do that? The rise is velocity, so that's meters per second, and the run is still seconds. When we divide meters per second divided by another seconds, we're actually finding acceleration. So the slope of a velocity time graph is acceleration. And you'll see by the units, remember that meters per second or meters per second squared. So that really sums up the first half of the unit. We looked at mathematical calculations for velocity, acceleration, and distance. And we also looked at analyzing graphs and getting some information off those graphs. The second part of the unit mainly dealt with forces. So here's what we talked about with forces. You should be familiar with the different types of forces that we talked about. So gravitational, friction, normal. You should know what those terms mean. But what are we doing with them after? Free body diagrams. Remember, we take an object, becomes the dot. Now, here's where some of you just need some reminders. If we've got, let's say we know that if we're near the Earth's surface, we always have gravity. And let's say this is for a ball on the ground. We've got gravity acting on that ball on the ground, and because it's resting on the surface of the ground, something must be balancing this force out, and that's what our normal force is. So just one key thing, we've got our gravitational force, we've got our normal force in the opposite direction. When you're drawing free body diagrams, don't just show the lines, but also show what force it is that we're talking about, and you're not going to have the opportunity to show that on this test, but on our final exam, you'll be doing a handwritten final exam probably. So this is something to keep in mind for those. Okay, and then you just want to know all of the forces acting on the object. If we had numbers for these things, then we want to figure out one step further what the net force is. So then that's where we move to next. We looked at the net force on something. And the net force is basically just adding up the sum of your numbers. But you have to think about direction. So the normal force is in the up direction, gravitational force is in the down, so they have the opposite sign. Okay, so the net force, you have to keep in mind the signs that go in front of things. So for instance, this one would be a positive up force plus a down force, which is negative. So you'd actually be subtracting that value to figure out what the balanced net force is for those two motions. Okay. Where did we go from there? Then we looked at Newton's 3 laws. I'm not going to spend a lot of time because you have my notes to go back to, but we have Newton's 3 laws. And so you should be able to, for this, if I give you real life examples of something that's happening to an object in motion, tell me which of the laws it best represents. So remember, Newton's first law is the inertia law. Inertia just means that when something, it's laziness of an object. Things that want to do what they're already doing. If it's at rest, it wants to stay at rest. If it's in motion, it wants to continue in motion, unless there's some forces that act on it. The second law has to do with this formula. Force equals the mass of an object times its acceleration. And the third is action, reaction. For every action, there's an equal and opposite reaction. And so for our second law, the examples I was giving you were different size vehicles with different size engines. So what we were playing around with was if we change the mass of something, how does it affect force and acceleration? If we change the acceleration of something by having a bigger engine, how does it affect the force needed and or the mass? So these are all related through this formula. And the action-reaction force, so for every action we apply on something, we're getting an equal and opposite reaction in the opposite direction. Okay. Okay, so one thing I want to go back to too, I caught in some people's assignments, I just want to make sure is clear. If we have, this is back to the math and motion. If we have, let's just say, an initial velocity of something traveling 3 meters per second in the east direction, and the final velocity of this object is, let's say, 2 meters per second, but in the west direction. These are important to keep in when you're talking about math. They have to be the same. It's just like if you're adding centimeters with meters, you have to change one unit into the form of the other. You'd either have to convert centimeters into meters or meters back into centimeters. The same thing has to happen with directions. So let's just say we had a time of 2 seconds, and we want to find the acceleration. Well, we know that the formula is v2 minus v1 over time, which would tell us we're going to take our v2, which is 2 meters per second in the west direction, minus 3 meters per second in the east direction, over our time, which is 2. Here's the problem. You can't add or subtract these unless they're the same units. So how do we change them? When they're in exact opposite directions or 180 degrees to each other, all you have to do is change the sign in front of one of them. So choose, if we want to change this to an east, then we change the sign that's in front of it. Or if we wanted to change this one to a west, we change the sign that's in front of it. So let's just change the first one that we have here. We want to make this east so that it's the same as this. It just becomes a negative. So it's negative 2 meters per second. This now is east, and this stays the same. Over 2, and now you can add these two numbers together. So we end up with negative 5 meters per second in the east over 2, and you end up with 2.5 meters per second squared in the east direction. Okay, so just be on the lookout for when your directions aren't the same. The only thing you'll ever have to do is just change the sign in front of one of them to make them the same. And I think that's it. So again, the next 2 days, here's the order you're going to do things in. Let's just go back. Print the formula sheet that I provide for you. Print the review sheet. Work through the review sheet with just the formulas for the math type problems. So it's just testing your knowledge of how much you can do on your own with just the formulas in front of you, because that's where you want to be by the time your test comes around. For any definitions and concepts, go back to my notes or use Google to help you. And then I'll post review answers. You can check your answers against those. And then finally, if you still have questions, you can email me if you couldn't figure out where you maybe went wrong on your own. Okay, and so don't forget, Tuesday is when that test is going to open up. It's going to be open up for a period of 2 days, but once you start taking that test, it's going to time you. So you're only going to have a limited amount of time. It's going to be no more than 75 minutes, what we would have in class. Probably going to be a little bit less than that. So you'll need to have your review sheet and your formula sheet with you so that you've got everything you need and that you can work through the test in the time that you have. Because once you start it, it's timing you and you only get one shot. Okay? One other thing you can do, and we can add this here, which is great. I have left our practice quizzes open. Go back and take another attempt at the practice quizzes. They're great practice for what you're going to see on the real test. Okay? And the answers will show up for you once you're done, so you should be able to get some feedback on that as well. Okay, so good luck on your tests on Tuesday, and please take the time to prepare for that.